Okay, with it. Good afternoon.
Good afternoon, sir. Good afternoon.
Okay. Today we are going to start vector lesson. This is our second class of vector. Okay, initially we have described what is a vector. What is a vector, and we have defined the thing. Then we have discussed about some special types of vectors. Then we have discussed about the magnitude or modulus of the vector and some special vectors like unit vectors, null vectors, and negative vectors. So those are the things that were discussed in our last class. Okay. Now today, in our class, we are going to discuss about two things. One is determine the magnitude of a vector using a non-vector. Okay, then after that we are going to discuss about mathematical operation of vectors. Mathematical operations of vectors. Okay. Here, right, the first topic. This is the first topic of today's lesson. How to determine the magnitude of a vector. How to determine the magnitude of a vector using a non-vector. Using non-vectors. Correct. Correct. You know, we have discussed about determination of also representation of vector in geometrical way, Pute. So, to do this thing, that means to determine the magnitude of vector using non-vectors, actually, now I'm going to discuss about if a vector system is given geometrical way means if they are represented in a geometrical figure, that means using a line segment, then you know the magnitude of that line segment is proportional to the magnitude of the vector. Okay, suppose you are given this kind of vector. AB is a vector. Then you can see it then. Suppose you are given this kind of vector system. Okay, and this vector is 10 Newton and this vector is 6 Newton. You don't know what is the magnitude of BC vector. You don't know what is the magnitude of BC vector. But you are given that this vector system is represented in magnitude and direction by this line segment. That means the magnitude of this vector is proportional to the length of this line segment. Therefore, we can consider this magnitude is represented by this length of this line segment. And then we can use our geometrical knowledge to determine the magnitude of the unknown vector position. Therefore, we can use our simple geometrical knowledge with it. So in this case, we can use Pythagoras law. No? In this case, we can use Pythagoras law to determine the length of this magnitude of this vector. Because now this length is proportional to 10 Newton, this length is proportional to 6 Newton, Therefore, definitely this length should be proportional to how much? How much? 10 squared minus square root of 10 squared minus 6 squared, no? That is 64. That means this should be represented. This length should be proportional to 8 Newton. This length should be proportional to 8 Newton. Right? But remember this thing. Remember this thing. If we are going to use this thing, that means use this method, definitely vectors, the given vectors means these two vectors. The given vectors should be represented in magnitude and direction by those line segments. Otherwise, we cannot do this thing. Right? Otherwise, we cannot do this thing. And sometimes you may be given a vector system using a direction only, in direction only. And therefore, in such cases, we cannot use this thing. Definitely, if we want to use this method, this vector system or vector system means the given vectors should be represented in magnitude, both magnitude and direction. Then the magnitude of this vector is proportional to the length of this geometrical figure. The magnitude of this vector is proportional to the length of this geometrical figure. So, if you know the geometry, then you can determine the length. You can determine the length. Therefore, easily you can determine the magnitude of unknown vector using your geometrical knowledge. Did you get my point, Pathirage Devi? We can do another example. Look at this one. Now you are given a rectangle. Suppose this vector is 10 Newton. A, B, C, D. And this vector is 5 Newton. And suppose these two vectors are represented in magnitude and direction using these lines, magnitude and direction. Then you are asked the value of magnitude of BC vector and magnitude of CD vector. So, what is the magnitude of BC vector? What is the magnitude of BC vector? CB vector. If this is a rectangle, tell me what is the magnitude of CB vector?
minus 10 Newton. 10 Newton minus 10 Newton.
No, magnitude. When you are saying magnitude, don't say minus. Magnitude means that is a value only, magnitude. When you say vector means magnitude and direction. Okay. Therefore, when you are saying magnitude, don't say minus value, because magnitude means that is the value of that vector. Therefore, that is just a value. Therefore, no need to say minus. It should be only a value, only a number. Magnitude nahi pute. So when you are saying a vector, then you can say both magnitude and direction. Okay. So what is the magnitude of CB vector? CB vector then?
5.
5 Newton. No? 5 Newton. It should be 5 Newton. Because as this is a rectangle, this length and this length is equal, and this length is proportional to 5 Newton. Therefore, definitely this length should be proportional to 5 Newton. That is our argument. This length and this length are equal. This length is proportional to 5 Newton. Therefore, this length also proportional to 5 Newton. We can use that argument. If this vector is represented in both magnitude and direction using this line segment. Therefore, if this vector is represented in magnitude and direction, then we can determine some unknown vectors. Therefore, if you are given a vector system or vectors in magnitude and direction, we can use their magnitude to determine the magnitude of some other vectors. In such cases, we have to use our geometrical knowledge. Okay. Therefore, what is the magnitude of CD vector? What is the magnitude of CD vector?
10 Newton.
10 Newton is very easy. It is 10 Newton. Okay, they write this one. If any vector system is represented by if any vector system is represented by a geometrical figure. If any vector system is represented by a geometrical figure in both magnitude and direction, come on. We can use our geometrical knowledge. To determine the magnitude of, we can use our geometrical knowledge to determine the magnitude of some unknown vectors. When the example one, if AB vector is 10 Newton, AC vector is 6 Newton, find the magnitude of CB vector. Here, CB is equal 10 squared minus 6 squared. That means 8. Therefore, CB vector, magnitude of CB vector is equal 8 Newton. Maybe the magnitude of CB vector is equal 8 Newton. 8 Newton. Then we can write this one. If AD vector is 5 Newton and AB vector is 10 Newton, the magnitude of CB and CDX. Well, normally see the magnitude of CB vector is 5 Newton. Magnitude of CD vector is 10 Newton. Did you get my explanation? मैं तेरा दूसरा मैं करने कौन किया? अरे ताशु. Sometimes you may be, sorry. Sometimes there may be some questions. We have to use in such questions. We have to use our trigonometric knowledge also only. My question is good enough. Like trigonometric knowledge को दान. Now you are given a right angle triangle. The hypotenuse of right angle triangle represents 10 Newton vector. Then you are asked to determine if the hypotenuse is 10 Newton. You are asked to determine AB and BC vectors. And this angle is given, that is 30. Hello. What are
So
you?
in that, so in that, 10 newtons in the rectangle, 10 newtons. Now we have studied the negative vector also, no? The direction is that 10 newton is line equal negative vector equal and parallel. So equal and parallel, and the opposite direction means negative vector, no, sir?
Yeah, this vector is the negative vector of this one. And this vector is negative vector of this one. And but we are going to discuss about magnitude only. Magnitude. Here we are going to discuss about magnitude. Okay.
Mhm. So
That is
negative
my topic is determine the magnitude of it.
magnitude. So we don't
And
need to see the direction, no?
yes, if you are otherwise, how can you say this one is positive, this one is negative? This
The
one is positive, this one is negative.
opposite
Huh?
sign, opposite directions, opposite.
Yeah, so if you consider this direction is positive direction, then this one is negative. If you
Yes,
consider this direction is positive, this one is negative. No?
yes,
And
yeah.
this may relative to the direction you choose as positive. Okay? But remember, your argument is correct. That means if this is a positive vector, this one is negative. Yes. This vector is the negative vector of this one.
Yeah.
And also this vector, this vector is the negative vector of this. This vector, find it this AD vector is the negative vector of CB. And also CB vector is the negative vector of A. They are negative vectors, but negative vector means negative vector does not mean we have to put negative sign. And it does not imply we have to put negative sign, because we have reversed the vector. We have reversed the vector using the symbol. The symbol represent it is into the other direction. Okay. Therefore, no need to write it as a negative vector here. Okay. Okay. Have done the exercise 3. Example 3.
5 Newton.
Okay.
BC 5 Newton.
BC 5 Newton. Yes. BC 5 is an AB. Now it's very clear. We can use trigonometric ratios. Sin theta or sin 30 is equal opposite side over the adjacent hypotenuse. That means BC over hypotenuse AC. BC means that is the magnitude of BC vector. AC means that is the magnitude of AC vector. No?
Yeah.
BC length means length again put hand. BC length means that is the magnitude of BC vector. AC length is the magnitude of AC vector. Therefore, sin 30 is half is equal BC. BC length means BC magnitude of BC vector. Magnitude of BC vector. AC means magnitude of AC vector. Magnitude of AC vector. Now you know magnitude of AC vector is given, that is 10 Newton. Magnitude of AC vector is given, that is 10 Newton. Therefore, magnitude of BC vector is equal, here 10 into half. 10 into half is equal 5 Newton. Did you get my point? පැහැදිලිද? හරිද? දැන් අපිට ඒ වගේම කරන්න පුළුවන් මේක. cos 30. cos 30. cos 30 is adjacent side over hypotenuse. Adjacent side means AB. Hypotenuse is AC. AB means AB length. Put AB means AB length. AB length means that is the magnitude of AB vector. That is the magnitude of AB vector. AB length is equal the magnitude of AB vector. So this is equal magnitude of AB vector divided by magnitude of AC vector. AC length means magnitude of AC vector. Therefore, cos 30 means 5 root 3 over 2. Magnitude of AB vector. Okay. Therefore, AB vector is equal 5 root 3. Make a 5 with A. AB vector is equal. So AB vector, AB magnitude of A, magnitude of AB vector is equal 5 root 3. Did you get my point? Okay. Now, take the tube. Take the tube. Take the tube. Then do the question number 2. Question number 2. Question number 4. Question number 2 and question number 4. There are 2 questions in question number 4. Therefore, altogether there are 3 questions. 3 questions. Question number 2 and question number 4. Question number 2 and question number 4. There are 2 questions in question number 4. Have finished? Have finished with it? Hadi. Karışık. Chris?
Yeah, AC 10 Newton, but the direction is the problem, so we don't know how to put the direction.
Which are put it?
Direct AC. Question number 2.
Yeah. Fourth one.
Second one. Two forces acting on a point. That one, no, so you asked to do.
Yeah.
Point at 8 and 6 Newton, perpendicular to each other. Direction of the
No direction mentioned. Second one.
yeah. How can we decide the direction?
Direction of which vectors, Putin?
Question number 2. Two forces acting on a point having magnitude of 8 Newton and 6 Newton and a perpendicular to each other. Find the magnitude and the direction of the resulting force.
You are mentioning which question? Second question, first page, second question?
First page, second question. Sorry. I thought second question. And I thought quantities are questions on the principle of vector addition. Not that one.
No, vector addition, no, still we did not do vector addition.
Right.
First question and second question.
Second
Okay.
question.
So second question and fourth question, right? Still the first part, no?
Yeah.
Second question and fourth question.
Second.
Fourth question, there are two parts.
Yes.
And
Yeah.
no, resultant force. Still we are not doing, we still not do the resultant force.
Square the magnetic of field. ABCD square magnetic field 10 Newton. 10 Newton vector is 10 Newton. Find the magnitude of the following. Support square is drawn to a scale. Suppose all the vectors are present to be 10.
Tarusha, are you referring to the same question?
Yes, sir. Now okay.
No, Tarusha?
Thanks.
The same question? No direction means?
The spherical square. Cool.
Okay.
Plus what? Plus what? What are the equal vectors? Zero vectors are equal vectors. Cool. What is this?
But okay, look at the question number 2. If ABCD is a square and the magnitude of AB vector is 10 Newton, find the magnitude of the following vectors. Suppose the square is drawn to a scale. ABCD. Newton. Correct. You are asked to determine BC vector, then BC vector, then CD vector, then DA vector. BC means this vector. BC, this one. CD, this one. DA, D to A. You have to mark the arrowhead according to the given arrangement. Okay? BC means B to C. Then CD means C to D. DA means D to A. Okay. Then AO, A to O, AO. OC vector means O to C vector. Then ODs are OB, OD vector and OB vector, O to B. So you have to mark the arrowhead according to given arrangement. Okay. So this one is 10 Newton. Now it is very clear you can determine BC, CD and AD at once because this is an X square. As this is a square, you know AB length equal BC length, BC equal CD length equal DA length. AB length means that is the magnitude of AB vector. BC length means that is the magnitude of BC vector. CD length, this length is equal to the magnitude of CD length, vector puti. And this length is equal to the magnitude of DA vector. Therefore, we can write this one as, write this one again. AB means that is the magnitude of AB vector. Magnitude of AB vector. Then BC means that is the magnitude of BC vector. And CD means that is the magnitude of CD vector. And DA means magnitude of DA vector. Magnitude. A length means a length of a line segment means that is the magnitude of some vector. Okay. Did you get my point? Did you get my argument? My argument is if you got my argument, please raise the hand. Okay. Then this one is given, magnitude of AB vector is given. Therefore, magnitude of BC vector is equal magnitude of CD vector, and that is equal magnitude of DA vector is 10. Okay. One is okay. The other one is AO. You know, as this is a square, this length is equal to this length. This one is equal to this one. No? And this is perpendicular bisector. Those are perpendicular bisectors. Anyway, you know this length is equal to 10 Newton and this length is corresponding to 10 Newton also. Therefore, if it is 10 Newton and if it is 10 Newton, then you can determine AC length. You can determine AC length. So if I apply Pythagoras law, Pythagoras principle to A, B, C triangle, then AC squared is equal 10 squared plus 10 squared. 10 squared plus 10 squared. That means 10 squared into 2 into 10 squared into 2. Therefore, AC means the square root of this one. The square root of 10 means 10 square means 10 would be 10 into square root 2. 10 into square root 2. So AC is equal to 10 into square root 2. Therefore, AO, OC, OD, OB all are equal to half of this value. Half of this value. So as this is a square, you know, got the AO equal OC equal OD equal OB all are equal to half of AC. Half of AC. ACO2. Therefore, AO means magnitude of AO vector. OC means magnitude of OC vector. OD means magnitude of OD vector. And OB means magnitude of OB vector. And all are equal. Half of this one means 5 root 2. 5 root 2. Okay. Here are the answers. If you got this answer, please raise the hand.
So you can use the cos 45 for the smaller triangle and find out. No, AOD cos 45.
Ah, yes. We can take it. This one is 45. This one is 45. Then you can draw a perpendicular. No need to draw a perpendicular. This one is 45. This angle is 90. This angle is also 45. Therefore, AO means 10 cos 45. Right? Well, this is 90. This is 90. There's another method. This is 90. And this is the hypotenuse. This is this one is on one side. This one is another side. This is the hypotenuse. Therefore, if you take cos 45, with respect to this angle, if you consider by cos 45, that is equal AO, that is the adjacent side over hypotenuse AB. Therefore, this one is AO, hypotenuse means 10 Newton. Therefore, AO is equal 10 cos 45, 10 cos 45. Cos 45 means 1 over root 2. Therefore, AO is equal 10 into 1 over root 2. 10 into 1 over root 2, you can. You can rationalize the denominator. You can rationalize the denominator. How to rationalize the denominator? You can multiply the denominator and numerator by root 2. Root 2 can multiply. If you multiply both numerator and denominator by root 2, root 2 to root 2, root 2 to root 2 means 2. Therefore, ours is 10 root 2 over 2. Again, 5 root 2. That is the second method. That is the second method. Did you get my calculation? If you get my calculation, please raise the hand. What are the equal vectors and negative vectors? Equal vectors. Equal vectors. These two are negative vectors. These two are negative vectors. Therefore, no need to worry about that thing. There are only one equal vector pair. Only one pair. That is AO and OC. AO and OC. That is the only equal vector pair. That is the only equal vector pair. Therefore, there are only one equal vector pair. AO vector is equal OC vector. Because the magnitude of both vectors are same, direction also equal, and they are homogeneous vectors. Therefore, they are equal. Then if we consider what negative vectors, there are a lot. AB and CD, there is one pair. AB and CD, they are into the opposite direction. AB vector and CD vector, that is one pair. Then BC vector and DA vector. There is another pair. Then OD vector and OB vector. OD vector and OB vector. And those are negative vector pairs. Third one is the equal vector pair. Okay. Did you get my explanation? Tena? Okay. Shall I rest? Okay, then both the okay. Now this is a square root. The magnitude of AB vector is 28. Find the magnitude of BC, AC, and CD vectors. CD vectors. This is a square. So if it is a square, you know, this angle is 45. This angle is 45. This angle is 45. So if it is a square, you can easily determine the magnitude of CD vector. That is 28. Magnitude of CD vector. Magnitude of CD vector. That is equal to 28. 20. Then, next one. If you consider about tan 45 okay. Not tan 45, no need to tan 45. BC also equal to AB. This is a square. So this one also equal to BC, magnitude of BC vector. Magnitude of BC vector because as this is a square, this length and this length and this length all are equal. This one is 28, this one also is 20. Therefore all are equal. Then you know this is a right angle triangle. Therefore you can determine the value of AC. You can determine the value of AC using Pythagoras law. Or you can determine the value of AC using trigonometric ratios. Trigonometric ratios use kala hana puluwan, or you can use Pythagoras law. Therefore, AC square is equal AB square plus BC square pote. Therefore, AB square plus BC both same pote 20. This one is 20A square plus 20A square. Therefore, AC is 20A root 2. 20A root 2 because this one is equal 20A square into 2. 20A square into 2. 20A square into 2. Therefore, if you take the square root of it, it is equal to square root of this one. The square root of 20A square is 20A. 20A into, sorry, this is AC. This is AC. Therefore, magnitude of AC vector 20A. Did you get that one? If you get that one, please raise the hand.
So they didn't put the unit. Do you need to put the units there? Newton. Not they are not
No,
put.
no need to use unit
No.
20 because that is a given one.
Good.
That is a given one. We don't know. There are a lot of vectors. There are a lot of vectors. Okay, the second one, you are given an equilateral triangle. Equilateral triangle. Shall I erase this one? BC is 20 Newton. And you are asked to determine the value of BA, AD, AD, CF, and BE. Okay, as this is an equilateral triangle, what can I say? You know, AB and BC are equal. AB and BC are equal. They are equal to the BC is equal to the AB. BC is equal to AB. And BC means that is the magnitude of BC vector. BC means that is the magnitude of BC vector. That is the magnitude of BC vector. And AB means AB length. AB length means that is the magnitude of AB vector. You know magnitude of BC vector is given, that is 20 Newton. Therefore, magnitude of BC AB vector also equal to 20 Newton. 20 Newton. Then, as this is a equilateral triangle, these perpendiculars, they are equal. They are equal. They are equal. Therefore, you can determine the value one. You can determine one value of either BE or CF or AD. Then that value that value is equal to the magnitude of other two. Okay. Then, if I determine value of AD, okay, you know, now this length is 20 Newton. And you know this angle is 60, the entire angle is 60. Because this is a equilateral triangle, it is E60. So if I consider about ABD triangle, if I consider about ABD right triangle triangle, you know the value of AB. You know the value of AB. And you have to determine the value of AB. So AB, this one is B. This angle is 60 and this one is 20. Now it is very easy to determine AD Pute. If I consider what sine 60, sine 60 means opposite side over the hypotenuse. Opposite side means AD. Hypotenuse is 20. Hypotenuse is 20. Therefore, AD is equal to 20 sine 60. 20 sine 60. Okay. Therefore, AD is equal to 20 into root 3 over 2 Pute. Root 3 over 2. 2 to 20 is cancelled now. Therefore, answer is 10 root 3. Therefore, AD is equal to 10 root 3. AD means that is the magnitude of AD vector. And you know, as this is an equilateral triangle, AD length is equal to BE and CF heights with it. Therefore, AD is equal BE and CF heights with it. Therefore, AD means the magnitude of AD vector. Magnitude of AD vector is equal magnitude of BE vector and CF vector. And you know magnitude of AD vector is 10 root 3. Therefore, that is equal to 10 root 3 Newton. 10 root 3 Newton. If you got this thing, please raise the hand. Leonardo Dosa. Okay.